discrete case, which we'll do in green here, we have the expectation of x is equal to the sum over all possible x values of x multiplied by p of, and that's capital X, okay? So bear in mind capital X is the distribution, little x here is the different values, so we're summing over all the different values of little x we can have. Okay, multiplied by the probability mass function of x. Okay, so this essentially means we multiply all the outcomes by how likely they are and add them all together, which makes sense. So example, we're going to look at the random variable being the number we roll on a dice. So what are our possible values of x? Well, our possible values of x are 1, 2, 3, 4, 5, 6. Bear in mind, I'm assuming this is a fair die, and yeah, meaning that each number comes up with equal probability, and it's a die from 1 to 6. So e to the x, not e to the expectation of x, is equal to 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5, you guessed it, times 1/6 plus 6 times 1/6. And we can take the 1/6 out. This is 1/6 multiplied by 1 plus 2, 3 plus 4 plus 5 plus 6, and that turns out to be equal to 7 over 2, 3.5. So note here that the expectation, the expected value, isn't a value we can actually get. So the expected value doesn't, the name is a little bit misleading, doesn't give us what we expect to roll, because this is obviously impossible. But what it does tell us is if we roll more and more and more and more times, we expect the average to be 3.5. Okay. So that's an important note to mention. The expected value doesn't have to be a reasonable value you can actually roll. Okay, it doesn't have to be one of the outcomes. So next up, we're going to just expand this idea to the continuous case, and if you, hopefully you've seen integration by now, but if you have, you'll know that integration sort of spans from infinite sums. So when we go into the continuous case, now we don't have a finite discrete values, we have infinite values, and we want to sum them up, so it's natural that we would introduce integration. If you haven't seen that, then I think I'll have a video coming out on Monday on that for the A-level maths course, so that'll be good to check that out. So e to the, I keep saying that, the expectation of x in the continuous case, this is equal to the integral over all possible values of x, x multiplied by f x of x with respect to x, where fx is the probability density function this time. Okay, so it's not how likely of a particular value is to come up, it's how likely a particular value is to come up relative to other values, because in the continuous case the probability that x is equal to a for any a is equal to 0. Okay, but that's aside, we don't really need that for now. So this is, yeah, natural. It's almost precisely the same formula, just we got some integration rather than some sums, but that's fine. Okay, what we'll go on to do in the upcoming videos is define variance, and to do that we'll need to define expectations of functions of x. So maybe you can think about how we could generalize this, and I'll either confirm or correct your efforts in the next video. So thank you for watching. I hope you enjoyed. If you did, please be sure to like the video. For now, that's it, and I hope to see you in the next one.